Let me now go back to the software and start with the qualitative models. For that, you need the program QGeNIe. QGeNIe is installed alongside GeNIe on your disk. So it's just a matter of typing QGeNIe and you will get it. It's there. So when I start it, you will see that the program is very, very similar to GeNIe, just a letter Q in the beginning. Q is for the qualitative GeNIe. In QGeNIe, every variable is propositional, binary, two states, true and false. So when you create a model, then you essentially create a proposition. Let me make the nodes a little bit bigger so they're nicely visible. There are two types of nodes, submodels and nodes that are qualitative. So let me create a node and give it the name of rain. When I double click on any of the tools in both GeNIe and QGeNIe, I get so-called sticky modes. So I can keep dropping nodes until I do something here again. So rain can influence, for example, the crop. The things that you collect, the grains that you collect when you are a farmer. When there is rain, usually there is high crop. Grasses need water to grow. A fertilizer is another node. And if you look at these nodes, to open them, you need to right-click and look at node properties. If you look at that node, you see that it has two states, true and false. In the beginning, of course, it's 50-50, but we can change it. So every one of these nodes has just two states, true and false. Let me add connections between them. Rain influences crop, high crop. When I draw an arc, I'll get a question, what kind of connection is this? What kind of causal influence is it? And there are four types of causal influences that we distinguish. A cause is an influence in which the parent makes the child more likely. Rain makes high crop more likely. It's a cause. A barrier is a cause that acts in a negative way. For example, if you the rain may have a negative effect on our vacationing. So if you create a node, enjoyable vacation, rain will have a negative influence on that. Requirement is something that is absolutely necessary for the child to happen. For example, in order to get COVID, you need to have a COVID infection. Some viruses need to be transmitted to you. Inhibitor is a requirement in the negative. So when an inhibitor is present, the effect will not happen. I'll show you a couple of examples of that. I'm just showing how to draw those things. So when I draw an arc, I need to choose one of the four influences. And I believe that these four influences are complete. So if you can think of any other influence, I'll be very interested in hearing that. Rain is a cause because it makes high crop more likely. Fertilizer is also a cause, I think. So I can create it quickly. It's a cause. A fertilizer in the field makes high crop more likely. They are, as you see, dimmed, which means that they are not working, they are unnecessary. You need to enter the parameters. What I just did is the structure. Structure and, of course, the states, which are by default true, false. So now, when I double-click on a node, what I can do is I can enter its prior probability. Probability of rain, well, it depends on the place on Earth. Let it be Austria. I don't know what the number of days is. maybe it's around 20% of all days in the year are rainy. There's precipitation. Fertilizer, well, some farmers use fertilizers, some don't. Let's 70% of farmers use fertilizers. Now, high crop. The thing that we enter here is no longer prior probability, but so-called leak. Leak is probability of the effect happening when the causes are absent. So there is no rain and no fertilizer. What is the probability that the crop will be high? I would say not very high, unless people supply water with in another way with sprinklers and fertilize. Maybe the soil is fertile. 5% looks like a good probability for that. As you see, I need one parameter for every node, and then one parameter for every arc. When I double click on this influence, here is the meaning of that number. When the rain is true, so there is rain, but there is no fertilizer, how likely am I going to get the crop high? %? Is it reasonable? So it's fairly strong influence. Rain is really important in having a high crop. Fertilizer influence, when I double click on it, it shows me what it means. Fertilizer is the probability of high, this parameter of for the arc is the probability of high crop when there is no rain, but there is fertilizer. I would think is probably lower, let's say 40% probability. You need water to dissolve the fertilizer and to get it into the soil. The model is ready. As you see, I needed one number per node and one number per arc. Now I can start using it. Let me make it visible as bar charts so that we see the states. Actually, you can also see the probabilities, the posterior probabilities by the colors. Now you can see both the probabilities of states and the colors. So now we can start making predictions. If the crop is high, how likely was rain that summer, that spring and summer, and how likely was the fertilizer supply? If the crop was low, fertilizer may have been still very likely, but probably not much rain. I can do also inference this way. So what if I observe that there was enough rain that summer? You see the probability of crop is high. You see that by the color also. The colors run from dark green to dark red through a whole spectrum. In fact, you see that spectrum when you double click on any of these sliders. This is the highest color. This is actually this is not really the good thing. Let's double click on this one. This is darkest green. This is the darkest red, and it kind of goes to light red, white in the middle, light green to green. Great. So we see posteriors as colors, and we can build these models quickly.